So hi guys, and welcome to the practical. The website I'm looking at and the website you're looking at are likely a little bit different, and that's because whilst I'm recording this, the website is still under development. So where you have your task and sequence is actually blank at the moment, and I've got the sequences here. But they're exactly the same as the ones you will receive. You will also notice that I have tabs open at the top here, whereas you will have them down here, and that's simply because they're not up and functioning properly yet as well. So we will begin straight away. So if we go straight to our sequences, the first thing we need to do is we need to copy all of these sequences and we need to pop them into a program called Cluster-LMega. Now you've got it here. I'm just going to use it here. So the first thing we need to do is pop it in and make sure that this says DNA, because we've got DNA sequences. And all we need to do then is press submit. Now the reason we're doing this is this program is going to align all our sequences, which you'll understand once you see it, and it's going to show us bits that need removing, and it's bits that we then need to keep, and then we take that into the next program which will read it and build our phylogenetic tree for us. So there are a fair few areas here which are poorly aligned that we're going to have to get rid of, and this is probably caused by the fact that the snow leopard had a much bigger sequence than everybody else, so he's got excess sequence left over that needs to be removed because all of the sequences need to be equal. So what we're going to do is we're going to do this manually. So we will copy all of this sequence and we're going to paste it into a text edit document. Now on a Mac I've got text edit, you'll need something similar. I would encourage you not to use something like a word processor purely because it can alter the fonts and it can alter how it's laid out, obviously by your fonts and your spacings and your settings on Word and things like this. I would encourage you to use a program that ends in .text. So what we need to do is we need to get rid of these really poorly aligned areas, and this is going to seem really strange because what we're going to do is we're going to be deleting large portions. So what we do is we will have to copy all of this because it's all really badly aligned. Where all the dashes are, it means that there's nothing there for anybody else, so we can't use it, we can't compare it if nobody else has it. Okay, so what we do is we delete all the way up to here, because here I can see that they've all got a portion, and that's great. We don't want to waste sequence that we've got, so let's just delete those blocks. Those blocks are gone. And what we're going to have to do is we're going to have to delete all the bits where they don't align, because it needs to be equal for everybody. So the first thing we do is I get the biggest one and I delete all of the gaps. And then you have to do the same for each one. So you scroll along and delete, and this is the most tedious bit, I'm afraid. And you get rid of all of the little bits that are unaligned and a poorly aligned sequence. So you do it for all of it, because it all must go. If I was to leave that there and be like, well, I've deleted the dashes, it must be aligned, and that's not aligned because everybody else has a different amount of sequence and it must all be equal. Okie doke. And now we're going to have to do the same at the top, because I see here we've got some poorly aligned sequence. Now this is slightly more difficult because it's harder to have a reference. So what I do is I actually leave the ones with the biggest gap till last. I line my cursor up and I delete it. So those two there have got pretty much exactly the same, so I don't need this one as a reference anymore, so I can delete that one. And you'll see here that they're exactly the same. So what I'll do is I'll delete that one. And I know it might seem a little bit strange to be getting rid of sequence that is of perfectly good quality, so ones without the gaps, but they have to all be equal. Okay, and then all we have to do is the last one, which is this one, and delete. And we can delete the stars as well. Doesn't make much difference, but we can delete them. So you'll see here that this is all equal and neat and lined up, and this needs to happen for the next program. The next program can't have any overhanging ends because that's classed as not aligned. It will class those gaps as evolutionary distances, and that's simply not the case. It's just a sequencing error. So what we do now is we copy all of this and we pop it into our phylogenetic program, which is cluster-LW2 phylogenetic tree, and you have it here. And UPGMA. Now the reason I've clicked UPGMA, and that's the only one that needs to change, sorry, I'll go back and do that again if that's confusing, because I did that a little bit fast, out of habit, I'm sorry. So you paste in your sequence, and there's only one clustering method we need to change, and that's UPGMA, purely because I know from the research that I've done prior to this tutorial that UPGMA is the setting that we need. They're just different ways of clustering the species. After this video you can try neighbour joining and see what difference it makes to the tree if you like, but for now, we're going to use UPGMA. Now, depending on where in the world you are, how good your internet is, and also how many people are trying to access it, this, like the previous one, might take a while, and again, you just pause. So here we have our phylogenetic tree, and it looks really good. I'm impressed with that. So we have our tiger, we've got our domestic cat, jaguar, leopard, lion, snow leopard, and we've got our clouded leopards down here. That's really great. So this is kind of what we wanted to end with. We have our phylogenetic tree here, and it tells us a little bit about them. But obviously it doesn't tell us exactly the same information that the scientists had. The scientists used really, really complicated methods, and I will just briefly show you if I can find their phylogenetic tree. Now theirs and ours are obviously going to be quite a bit different. They've used a different program, and they've used really complex statistics and things like this to make sure that they're sure that that phylogenetic tree they have is correct. You will also notice that we have two options here, which are real and cladogram, and I'll just quickly cover those. So that's a phylogenetic tree, which is what they have. So you see how the lines here are slightly different. So domestic cat ends here, the others kind of jut out a bit. And these guys are actually your clouded leopards. They've just got different, they sampled in the wild and got different samples. So these is what these are here. But we don't really need to worry about that. We just need to know that they are the two clouded leopards. And we have a cladogram option, which is where it's all neat and lined up, which I find it's easier to read. So if you prefer this one, which I think you will because it's far easier to see the lines, then I would say by all means do use this one. So I'll just go through this. So you can see that we are matched them. So we've used a domestic cat and an outgroup, and we know that the domestic cat and the big cats are separate. They are taxonomically distantly related, which is great because they make a fantastic outgroup or root species, which we need. We need a root species so we can make the inside side of our phylogenetic tree. So let's just compare. We also have a domestic cat. I know it sits on top of the phylogenetic tree here, but that really doesn't matter. It sticks out, so it's acting as an outgroup species. So in the middle, I know they're slightly different. So you have tiger and jaguar are more closely related on that phylogenetic tree, and for us, they're also quite closely related. And then we have lion and snow leopard, and on our phylogenetic tree, we've got lion and snow leopard, which is great. And then we've got a leopard here, and we've not included a leopard, and don't need to worry about that. We just couldn't get hold of the sequence. We've just not included them. Okay. But the important information is here. Now this is the final paper, and they had papers before this one where the idea came and they investigated it. So this was just kind of like the final paper to investigate whether they were really separate or together, and the paper concluded that they were indeed separate species. So although we can't directly see that on our phylogenetic tree, we can see that they group together very, very well, just like here. And what they've done is they've got all the different samples and they've separated them. So N. diardi, so we'll start with N. nebulosa, which is obviously the species that they were all classed under, and what the phylogenetic tree is saying, and what the authors are saying, is that they're separate enough, and they want to call these guys Neophilus diardi, and they want to call these guys Neophilus nebulosa. And the difference between Sumatra and Borneo are where the samples are from Sumatra or from Borneo. But essentially what they're saying is that they are separate and that they are different enough to be classed as different species. So this is the paper that actually is used by the IUCN, along with all the subsequent papers that came before it, to say, yes, we do believe that they are indeed, my scientific opinion is that they are indeed separate species and they need a separate conservation plan. And they do indeed say that. If we just scroll down to the discussion, which is where they discuss their results, they look at the range and things like this. They say that essentially they need separate conservation managements. They are two distinct populations in Borneo and Sumatra, and they should be managed separately. So they are separate to protect genetic diversity on which future evolutionary potential depends. So our paper gives good example of the importance of taxonomic splitting for conservation, because the two species and distinct populations on Borneo and Sumatra face a much greater risk of extinction due to smaller distribution ranges than previously assessed on the former classification. So these guys recommended that they be treated separately, and they have been listened to. If we go to the IUCN Red List, which is a fantastic website, we can type in Neophilus nebulosa and type that in. Clouded leopard. We can find out a little bit about him. So here we are. So he is classed as separate, and the paper here, along with the subsequent papers, of course, they all worked in a group. Scientists works in groups. It's very rare that you do one paper and it changes things. You often have to do multiples to make sure that you're sure. So classically considered a single species, the clouded leopard has been recently split into 2 species, and don't worry about how they did that, it's similar to what we've just done. So here is the paper here, Wilting et al. 2007, and that's the paper we have here. So they made a big difference. So if you want to take a read of this and look at their current management plan, you can indeed. What you can then do is type in Neophelus diardi, and that's the sunder-clouded leopard. So they've definitely separated them, and again, classically considered a single species. They've now been split up. Excuse me. So if you want to take a look at this and you want to look into more detail, then by all means, I've put the papers on the website for you to take a look at if you do want to look at the papers in more detail. What I don't want you to do is be afraid of the amount of detail and the really complex phylogenetics on there. What we've just done is a kind of basic phylogenetics. It's what we call guide trees, where if I wanted to take a look at something of a phylogenetic relationship, I would build a guide tree first to give me a rough idea of what I'm looking at, and then they'd go on to do proper, very complex phylogenetic analyses that we see in this paper. So I really don't want you to worry about trying to understand the methods and the results. It might just be interesting for you to read the introduction and the discussion in the abstract, because that gives you a little bit of background information and then it gives you their recommendations. But please don't get too hung up on the fact that our analysis will be very different to their analysis. Okay? Although we have used one of the same genes, we've used cytochrome V, which is one of the ones they've used, which is why we have a similar phylogenetic tree. Excuse me again, guys. So well done on everything. If you have any questions and you do need more tutoring, please do post on the forum, because I do monitor it and so do my friends and colleagues who I've asked to help me out, and we can try and help you, because there are maybe some questions, some bits we haven't covered in detail. If there is a significant portion of information that you want covered, maybe you'd like me to go through this paper in another kind of screencast, then by all means request that and I'll absolutely do that for you. So best of luck in your final exam, guys, and well done.